Alright guys, welcome to our video today on the piping system for our design assignment. This is our group. I am Rishendra. This is my student ID 012683, and these are my teammates Megat and Aidan with their following student IDs as well. To begin, I'll be passing on to Megat.
To start the presentation, I'll just go over the objectives of the report that we did. So the main objective is to come up with the design for the piping system, to come up with the best design in order to make the most ideal piping system. So in order to do that, the first thing we have to discuss the fitting use, the type of fittings that are the best to be used in the piping system to make it work efficiently. And then we use the program SolidWorks to come up with the design, to draw and design the 3D model of the piping system before it can be passed on for the manufacturing. And there we came up with the dimensions and the features of the piping system in the SolidWorks. So also we had to use certain scientific theories and principles, because we have to deal with the workings of the fluid mechanics of the piping system and all the properties. So we use we have to apply the Pascal laws and Pascal law and Bernoulli equation to see if the fluid can be applied with the piping system that the design that we came up with. Okay, next. So in this slide is the functions of the piping system. The main function is to transport fluids, so which include liquids and gases. So that's why we had to come up with the most ideal piping system in order to work with the fluids that we have to deal with in the industry. So the piping system is the interconnection of all the pipes in the system to make up one piping system, and that includes all the fittings in between all the pipes. So as you can see on the slide, there's the Bernoulli equation that we had to use to work out the mechanics of the fluid that we have to deal with in order so that we know how is the best what's the best design to use for the piping system. Okay, next. Okay, next I'll pass to Aidan to talk about the literature review.
There are several important factors to consider, such as what fluid dynamics behind the flow of fluid inside the pipe, and how does the size of the pipe and the types of the fitting affects the fluid flow inside the pipe. All right, next. First thing first, there are three main important fluid mechanics that's happening inside the pipe: rate velocity, the flow rate of the fluid, and the pressure of the fluid. So the velocity of the fluid represents how fast does the fluid is flowing inside your pipe, and the flow rate represents the volume of the fluid that flowing inside the pipe within a period of time, and the pressure represents the energy needed to push the fluid from one point to another point. So what are the relationship between these three? The fluid velocity can be affected by the pressure of the fluid based on Bernoulli's principle. For example, if you try to increase your fluid velocity, the pressure of the fluid will decrease. However, if you increase the fluid velocity, the flow rate of the liquid can also be increased. How does pipe size affect the flow of fluid inside the pipe system? For example, the bigger the diameter of your pipe, the bigger the flow rate of your fluid. However, but if you increase the diameter of your pipe, you also reduces the fluid velocity in the meantime. So meaning, by increasing your pipe size, your pipe internal diameter, you can increase your flow rate of the fluid without making any changes to your velocity. So what does engineer always do to reduce the cost of the material is usually they try to increase the flow rate of the fluid by reducing the diameter of the pipe. But by doing so, you also increases the velocity inside the pipe. This in turn will cause more wear and tear damage because there will be more fluid molecules rubbing against the wall of your pipe, making it easier to damage. So next. All right. So what are pipe fittings? Pipe fittings is used to connect your straight section. Try to add different sizes or shapes to alter your direction of the fluid flow. For examples, one of the most common types of pipe fitting is the 90-degree elbow, which changes your fluid direction 90 degrees. So, but however, despite their convenience, pipe fitting can cause pressure loss due to friction as well. So it's important to understand and limit the number of pipe fittings that you're going to use inside your pipe systems. All right, so next, I will pass it to Rishi to explain about the material selection for our design.
So for the material selection for our pipes, we have come up with 5 different materials which we had researched. The first being galvanized steel or iron, followed by polybutylene, then copper, and then unplasticized polyvinyl chloride, otherwise known as PVC, and lastly steel. So what about galvanized steel or iron? It is a common material for conveyance of water and waste. It is galvanized in the name, which means that it has pre-treatment cleaning in molten zinc. But its popularity is actually decreasing in industry, and the reasoning behind this is that there are limits of where it can be used, and also because of the internal corrosion it has. But the finish of it is, how do you say, it looks very good. Therefore, some many buildings will want to use this material instead rather than PVC because it looks a more luxurious view, as it matters to them in industry as how they look. The next material will be polybutylene. This material is appropriate material for the conveyance of drinking water in domestic dwellings in some countries developed in non-metallic tube systems. It is light and easy to handle, but due to problems with leaks at joints leading to substantial water damage in buildings, it is actually forbidden by plumbing codes in the USA. So as you can see here, it does have its own issues, and we had our concerns with using this material due to this. The next material will be copper, and it is highly versatile and smaller in total diameter compared to galvanized steel and pipes and fittings. This means that maybe the overall mass could also be less than using steel, which gives it an advantage. And we have also read that in the hands of an experienced installer, it is easy for them to work with. Copper tubing is relatively light to handle, as mentioned before, due to its thinner wall section and is available as needed in coil type or straight lines. So it gives the workers more, or the designers more options to choose from. Wherever sufficient insulation is not provided, heat loss may become a problem. So this is a concern. And the inner wall of the piping system will be eroded by high flow and velocity. So if we were to use copper, we have to make sure that the piping system, the flow rate is constant, as the increase in velocity could cause corrosion in copper. And lastly, there's a need for caution to ensure that grounding links are isolated from piping systems and electrical wiring. And we all know this because copper is actually electrical conductive material, and this could be dangerous actually if not taken care of properly. Next, we have unplasticized polyvinyl chloride, otherwise known as PVC. And as it's not a metal, it actually does not suffer from any corrosion issues, but it is vulnerable to physical harm because it's very light and it's relatively, you can probably break it if you step on it pretty hard. It's an easy material to break, and it's brittle when exposed to ultraviolet light. It is extremely light to handle, and it is widely used around the world. It is a well-known material and people commonly use it. It's also very economical. But if subjected to heat in excess of 65 degrees temperature, the material will soften and deform. So for perhaps fluids such as hot oil, this is not a material you want to choose. The next slide will be about the steel. Steel has large hollow tubes are steel pipes used for a number of purposes. They are either made by welding or seamless tubing. It is used to transport goods such as oil, natural gas, water, and even sewage. As mentioned before, PVC could not transport, maybe not all of this, but some of it PVC could also handle. It has excellent resistance due to its toughness. Its high strength of steel, however, makes it difficult to bend and shape. So this makes it a bit more difficult of material to work with and could make it like we need more pieces of pipes to make the system work. It is also more heavy and could be more dangerous for workers to handle. So all in all, our selected material was PVC due to reasons that it's more economical. The inner surface of PVC piping also be more smooth, and this could eliminate maybe dirt buildup in the system. The overall mass of PVC will also be reduced greatly, and this not only makes it easier to install, it also makes it safer to install. And that will conclude that part. Following this, we have the 3D model and design elements. As you can see here, the picture of the sketch model, they give the parameters to follow, and also calculations will be based off this as we use these parameters to follow for our designs in the 3D model. Here we have the drawing in SolidWorks. This is the model described in drawing, following all the parameters, as you can see here, based on the exact dimensions that are given. The next part is the test design. So we actually came out with a test design in SolidWorks assembly to better understand SolidWorks for the final design. So we can see here in the system, tees, gate valves, and flanges were all used for various purposes. The pipe fittings are components of pipe that will help adjust the flow path, such as elbows and tees. So we can see here that many different types of fittings are used, but not all were used in our final design. One of the fittings were pipe tees. So what are pipe tees? Pipe tee is a type of fitting which is a T-shaped, having two outlets at 90 degrees to the connection to the main line. So it's used mostly to turn the water split around, maybe around the room or corner. You can use this. It's used also to distribute two-phase fluid mixtures into pipeline networks. Next, the gate valve. By inserting a rectangular gate or wedge into the direction of moving fluid, gate valves operate. So that's how gate valves will operate. Threaded stem that attaches the actuator, usually a hand, wheel, or motor, to the stem of the gate controls them. Why are gate valves not usually used to control flow? Well, that's because the fluid flow rate is not equal to the amount of opened by the valve. So this makes it difficult to manage for some cases. It could also lead to some damages due to fluid flow velocity and whatnot. Lastly, will be flanges, and flanges were actually used in the final design. Flanges can be used to connect long straight sections of the pipe, and they are often used at the ends of routing to connect pipe or tube to fix components such as a pump or tank. Flanges enable you to quickly assemble or disassemble pipes with flanges, and this was key for us as we wanted to make it easier to transport the pipe to go and to install it. As well as maybe perhaps needing to change it, flanges will help in this. Here we have the 3D models in SolidWorks. We have the two pictures here, giving different views of it. This was done in assembly in SolidWorks. The steps for 3D model were as follows. The dimensions of the final product were taken into account. As in the sketch, the material selection was decided amongst the group members, as in we all had to decide which material was the best. We had meetings for this, as well as research sent to a group. Research was done on how piping system was made in SolidWorks, and we had to test design. So we followed some inspiration online and whatnot, and we came up with a design on SolidWorks. Lastly, the additional parts were decided, as in flanges or valves. In this case, flanges were added to our assembly in SolidWorks. For the simulation, we used a software called Pipeflow software. It was used to calculate pressure loss and flow rate in pipe systems. Software models open closed loops, components, and pump curves. The following was the website of which we downloaded the software from. Here I have a short video to show you the SolidWorks demonstration, and I'll be going over the video as it plays. So as you enter the SolidWorks assembly, you have to enable the SolidWorks routing. Lastly, change this option, change it to plain white, the background. Slip on well flange. This is just an example, so you just use any random number there. Save it. That's the flange. Once it's saved, you can see it constructs a pipe now. And you can drag and pull this pipe as well as attach lines, and this will start building your pipe system. You can also use Smart Dimension to space out, give the correct dimensions for your sketch or your pipe, attach another flange, and this could be how you close off the system. You can also add gate valves and reducers and whatnot, but for our case, we do not need to use this as we wanted to keep the dimension constant. Next, I'll be passing it on to Aidan to continue with the results.
Alright, so on the right, you can see this is an example of our pipe model, a 3D model created from SolidWorks, and from the left, there's the result gathered from SolidWorks as well. So what does the table show is that it helps that what are the average velocity, the pressure, and the flow rate flowing through each pipe which is used in our design. So in total, as you can see, we just a total, not including the pipe fittings, and it shows the actual length of our pipeline, and also show the average velocity and flow rate and pressure flowing in each pipe section. So let's take a look at pipe 1, which is at the most top of our design model. So from pipe 1, you can see from the tank input, the tank provided a pressure of at least 20,000 kilopascal into pipe 1. So after the liquid exited pipe 1 and trying to flow into pipe 2, you can see that the water pressure has been reduced to 1,135 out of 2,000. This means that there are at least more than 800 of pressure was lost as it's flowing through pipe 1 due to friction. So by the time the fluid flow from pipe 1 until pipe 3, the pressure left is only around 600 kilopascal, which is definitely not enough to push from pipe 3 to pipe 11 to our housing and our housing water. So what do we do to our design here is like we design a directly vertical around like 100,000 of millimeter of pipe, which help us to build up pressure by the time it reaches the end of pipe 4. This can be shown in the result as well, that our pressure loss is in negative value. This means that the vertical length of this pipe 4 help us to create a height of a column of water, which increases the output pressure as it's flowing out of pipe 4 into pipe 5. This can be seen in pipe 7 as well, which is also vertically downward towards the ground, which also helps us to create an additional pressure, which helps us to push the liquid throughout the pipe system into the residential tank. So by the time it reaches pipe 11, the total output pressure that is obtained from the simulation is around 15,000 kilopascal, which is more than half the input pressure given in the elevator storage tank. So in discussion, next slide. So in discussion, you can say that our pipe system has an energy conservation efficiency of at least 70%. So our output flow rate is around 0.019 volume per second. Consider if it's working in a perfect system. So with 0.019 volume per second, it takes at least 1 hour and 8 minutes to fill up a housing tank given in the assignment. So now I'll pass it to Megat to conclude our presentation.
Okay, thank you, Aidan. So for the conclusion, to conclude the presentation, we did the research and design in the report, and that we have outlined in the report, and that shows the entire process that we did in order to come up with the design for the piping system. So as you can see in the report, we applied certain principles and theories in order to during the research and design processes in order to come up with a design that has the best efficiency and functionality of the piping system. Yeah, that's it. Thank you.
And that will conclude our presentation and this video. Thank you all so much for watching.